action.
Hello, boys and girls. This is the course of Environmental Science, which is meant for BTech third year and fifth semester. The code for this particular subject is AMC 501. As you know, this is the mandatory course of BTech third year, and I am G. Chakraborty from Department of Chemistry, welcoming you to this course of Environmental Science.
Now, in the last lecture, we people have clearly seen that in environment, right, what the major aspects are, right? We have come across 14 lectures since this is the 15th lecture, and this lecture is actually the part 2 of water and its pollution, right? Now, in the last lecture also have been explained that in this 14 lectures, what the people have seen, lecture number 1 to 6 were of general environment, right? Lecture number 7 to 13 were air and its pollution, and from the very last lecture, that is lecture number 14, we have been starting the water and its pollution part, right? Now let us have a quick recap of the things that have been done in the last lecture, that is lecture number 14, okay, the part 1 of water and its pollution. Now, as we people have already discussed that we should clearly know about water before determining that whether given sample of water is polluted or not, because without having proper knowledge of water, how can we say that water is polluted or not, right? If we are unable to distinguish between good and bad, then we cannot determine which one is good, which one is bad, right? So it's very important that first we should see which one is good, what is the actual parameter we should follow. Then only we can understand what changes in parameter have occurred, or what changes in quality has occurred, whether the quality has been deteriorated or the quality has been enhanced, or whatever has been happened. In order to know that, we should clearly see and we should have clear knowledge about the quality of water, okay, about the parameters that determines the quality of water. Now, if we look at the parameters, in the last lecture we have briefly studied that the environmental quality parameters are designated in such a way that there are certain laws about the water quality, okay, water quality laws, right, and that will determine whether the quality of a water is good or bad. Similarly, there are the quality of water will be judged on the basis of the purpose of using that water. If we want to drink water, then on that purpose the quality will be judged. If we want to have water for some other purpose like washing, bathing, or any other activities, right, so water will be judged on that quality. So water will be judged basically depending, water quality rather will be judged depending on the parameter that how and for what purpose that water is being used. In addition, water is the place of many living organisms, especially fishes, right, aquatic organisms, aquatic plants. So basically, whenever considering the water quality, we should think about them also. We should see that the water that we are discussing is of good quality for fishes or aquatic animals, or it is not comfortable for them, right? In view of this, we have come across several parameters, right? We have come across physical parameters, which includes the temperature, the conductance, specific gravity, density, heat capacity of water. After that, we have seen the chemical parameters, which sees that whether the water is acidic or basic, what is the pH of water, and several other chemical factors, just like the water is hard or not, what is the alkalinity of water, what is the salinity of water, that we have seen. And further we have seen that what are the biological components or the biological parameters to be tested, that is different by microorganisms, right, that are merely present in water, okay. After this, we have seen what is salinity, how salinity is important, and what are the properties of saline water, how salinity is calculated, okay, because we know that majority of the water bodies present in the earth is saline, okay, so we need to check that, right. Now, in this particular lecture we will see that what BOD and COD is, right? So in order to find out that what are the lecture highlights, let us go into the details of this particular lecture. Okay, now as you can see, this is the second lecture of water and its pollution, that is water and its pollution part 2. And in this lecture what we will be having, we'll be having these things, namely dissolved oxygen, very important thing, DO, and then the most important thing, biochemical or biological oxygen demand, that is BOD. Then we have 5-day BOD test, then we have BOD reaction rate constant, and finally we have chemical oxygen demand or COD, right? It is not cash on delivery. People may think it is cash on delivery, COD, but it is not cash on delivery, rather it is chemical oxygen demand. Okay, so let us go to the next slide where dissolved oxygen has been mentioned here. Now as you can see, there is a wonderful picture present here which will explain the every bits and bits of this particular thing which is called dissolved oxygen. Okay, so everything will be explained briefly. Stay tuned and listen very carefully in order to understand what is dissolved oxygen and how dissolved oxygen determines the population of fishes and other aquatic animals. So the picture implies fishes, but actually it will also be of same impact for the other aquatic organisms. Okay, so let's see what we are having. Now first question arises, what is DO? DO is not that whatever we add to our body, okay, in order to remove foul smell and all. That is also a DO, but this DO and that DO are quite different. Okay, dissolved oxygen, what is the meaning? The amount of dissolved oxygen present in a water body is an important measure of the quality of water. Yes, if DO or dissolved oxygen is good, water will be considered good for the aquatic population. If dissolved oxygen is less, then water would be considered bad for the aquatic population. Question arises, what is dissolved oxygen? What is dissolved oxygen? The amount of oxygen that is present in water, that is called dissolved oxygen. Now, this particular oxygen actually is contained inside water, right, and can be measured by several methods. Okay, dissolved oxygen is very important. Now you can see that DO depends on physical, chemical and biological activity of the water body. If the temperature of the water body is very high, then DO will be less. Why? Because oxygen is nothing but a gas. Now whenever you will increase the temperature, what will happen? The gas will show a tendency to move out of the liquid substance, right? So whatever is dissolved will be undissolved if it is a gas. Oxygen is a gas. So if temperature is high, then amount of oxygen that is present inside water will become gradually less, right? And if DO is less, quality of water is getting deprived or deteriorated, right? Again, if pressure is very high, then what will happen? More and more DO will be there, because if pressure is high, then gas will be liquefied, and if oxygen is liquefied, then it will move inside water, right? So low temperature and high pressure are preferred. Okay, similarly pH changes can result in oxidation or reduction of the dissolved oxygen, and different biological organisms also can affect the dissolved oxygen present in water. Okay, so the amount of DO definitely depends on physical, chemical and biological activities of the water body. Okay, now the question arises that how we can determine the amount of DO present in water. It's clearly written the DO content of water sample can be determined iodometrically by Winkler's method. Now here we are having something that we know. What is the thing? This Winkler's method, right? An iodometric estimation of DA. If you have done the experiments present in first year of BTech syllabus, right, in the chemistry lab, okay, classes were taken by us only, you might be remembering that yes, we have done this iodometric experiment of determination of DO. Right, what the experiment contains, we used to take a sample of water, then we used to add some Ki and acetic acid and all, right? The Ki used to be oxidized as I2, and then the liberated iodine was to be back titrated. This type of titration is called Winkler's method, and we actually have performed this titration because this is a part of the syllabus of BTech first year, right? Now you are in second year or third year, so you definitely have performed, I guess, this experiment. Okay, this is the way of finding out DO, right? Now let us move a little bit on, and moving on, what we people are seeing, we are seeing that the color starts from red and ends at green. Okay, that's why I have chosen blue. Okay, blue colored pen I have chosen. Now parts per million, that is ppm of dissolved oxygen. If 1 part per million DO is there, then you will see only the skeleton of fish. If 2 parts per million is there, then also skeleton of fish. If 3 parts per million, then also skeleton of fish. If 4 parts per billion, then there will be nothing. If 5 parts per million will be there, fishes will start, growth of fishing will start. If 6, it is good. It is, if 7, it is better. 8, it is excellent. 9 is outstanding. 10th, it is best. Now what does it means? Whenever we are having the water quality having parts per million of DO 1, 2 or 3 parts per million of dissolved oxygen, then what we will say? We will say it is too low for fish population. So fish population will not be there. Now if that is 4 then or 5, then it is very much stressful for a fish to live, right? If 6 or 7, then yes, fishes will develop and their families will increase, right? They will breed. And if 8, 9, 10 is there, then it will support abundant fish population. Plenty of fish. Being a Bengali, will be very happy, right? So the amount of fishes directly depends on the amount of DO present in water. Now, one more thing is there, you should need to know that this is not only about fishes, right? It is all about all aquatic animals. Now after the topic DO, we should see what this particular BOD means. Okay, because BOD is the next topic that people are having. And remember, BOD is the most important topic of the total water pollution part. Most important topic. Why I'm saying so, you will come to know later. Okay. Now what is this BOD? Now BOD has two names basically. You can say biochemical oxygen demand, or you can say biological oxygen demand. Somebody will say biochemical, some other will say biological. Both are actually BOD, right? So both are same. Okay. Now we will see what the word BOD actually means. Okay. Now let us see it. So it is the amount of oxygen required to oxidize organic waste aerobically by microorganisms through oxidation process known as biochemical or biological oxygen demand. Okay? So whatever amount of oxygen is required, by microorganisms. Okay. Now why microorganisms will require that oxygen? In order to oxidize organic waste that are present in water. Okay. Again I'm saying the amount of oxygen required by microorganisms to oxidize the organic waste that are present inside water is called BOD, right? Now here one important term has come up. Let us highlight it out. The term is aerobically. Aerobically means in presence of air, right? There are two terms, aerobically and anaerobically. Aerobically means in presence of air, anaerobically means in absence of air. Okay. Now it is expressed in milligram of oxygen required per liter of wastewater, means the parameter of BOD estimation is milligram per liter, right? Aerobic decomposition of oxygen, organic matter by dissolved oxygen. Okay, let us see the reaction. Organic matters plus oxygen plus microorganisms. What they give us? CO2 plus H2O plus stable salts plus new cells. These new cells are nothing but microorganisms again, and CO2 and H2O definitely will be released if oxidation occurs, right? So it is quite an easy mechanism of reaction that they follow, and it is written the aerobic decomposition products are non-objectionable, means this particular products that are being formed, that is CO2 plus H2O plus stable salts plus new cells, whatever products are being formed here, they do not create any harm to the environment because these are natural substances. Okay? So they will not create any harm, right? So they are non-objectionable. That is whatever is written here. Okay. Thus, oxygen-demanding wastewater is severe pollutants and require special attention and care. Okay. Thus, BOD test is very important and essential. So, oxygen-demanding waste, right? It requires attention and care, and BOD test is very much important for us. Now, BOD test is important for us not only for the quality of water but also for the exam, right? I was joking. Yes, it is very important for exam, but that is not the thing. The thing is that BOD is very important. Now, how BOD test is conducted? BOD test is conducted for a span of 5 days. Okay, this particular thing is called 5-day BOD test. Okay, now how this is done? See, BOD test can take several weeks for completion, thus making it impractical for routine purpose. Now, BOD test is a routine test, but if one test requires 1 month, just like COVID-19 test. If you are testing COVID-19, but it is this the result of this test is requiring say 1 month, then in that 1 month you will recover, right? 15 days you will recover. So what is the need of that particular test? Nothing, total in vain. Okay, so same thing happens for BOD test. If you are doing the test for routine work, then if it is taking too much long time, then it is worthless, right? That's why BOD 5 has been implemented. Okay, so that is what it is written. As a result, 5-day BOD test is introduced. Okay, it will record 5 days. 5-day BOD test means amount of oxygen utilized by microorganisms for biodegradation in first 5 days, right? So a span of 5 days is taken, and in this span of 5 days, whatever the BOD is, whatever the demand for oxygen for the microorganism is, that is to be tested. Okay. Now, precautions should be taken during the experiment. Okay, let us see what precautions are taken. Option A, number A is the stopper of the bottle must be fixed properly so that replenished DO by biodegradation is not filled up by oxygen from air. Yes, restriction of entrance of oxygen should be there. Whatever container you are using, the lid of that container will be 100% leak proof so that air cannot enter from outside. If air enters from outside, our result will be erroneous because we are taking a waste and we are using the air that is present inside, right? We are using the air that is present inside in order to oxidize the waste, right? So it should be fixed properly so that the replenished DO by biodegradation is not filled up by oxygen from air. Okay. Now, number 2 says that the bottle must be kept away from sunlight, otherwise algae will produce oxygen by photosynthesis. This is also very important. Sunlight cannot be allowed to come close to the bottle, or you can say bottle will not be allowed to close to sunlight, because what will happen, the algae will produce photosynthesis, thus again our result will be erroneous and we will not get this particular fact, right? Particular fact means the amount of BOD, right? Third thing is, it must be carried out at 200, no, it will be 20 degrees Celsius. 20 degree Celsius, right? So we have to correct this to should be 20 degrees Celsius instead. Okay. So it should be carried out at 20 degrees Celsius for its standardization, and as saturated value of DO at 20 degrees 9 gram per liter. So how BOD can be calculated? This is the formula. Let us mark the formula. Okay. This is our formula of BOD, right? What the formula is? It is saying, let us beautify it a bit, right? Okay. So what the formula is saying? It is saying that BOD5 is equal to DOI minus DO5 by DOF. DOI means initial DO. DO5 means whatever DO has been, whatever DO is left after 5 days, and F is the dilution fraction. Okay, it is written clearly. Initial DO considered or DO after 5 days, and this is a dilution fraction, right? Now this formula is very, very important for us, so we have to remember this formula very well. Okay. Next, what we are having. Now this formula is elaborated in this way, that F is equal to volume of wastewater divided by total volume of wastewater, right? Now a saturated BOD bottle of 300 ml thus contains F equals to volume of wastewater by total volume of wastewater. Now this total volume of wastewater is nothing but 300 ml for a 300 ml bottle. Okay. Now in our calculation for BOD 5, we have assumed that the water used for dilution has no BOD of its own, right? We have used BOD free water. Okay. In order to avoid confusion, we have used that. It is only possible if we use a boiled distilled water and keep it airtight prior to addition. If the distilled water is boiled, then what will happen? Whatever DO has been present inside the water, that will be removed, right? So it is 100% BOD free, right? That's why if we are using this, we can assume that there is no BOD of its own. The water is having no BOD. If it is not so, then we must seed the water for dilution with microorganisms so that there is sufficient bacterial population to carry out biodegradation. So in such case, actual BOD of wastewater will be BOD of mixed sample minus BOD of water for dilution. This is very, very important. Okay. If you are using boiled distilled water, then it is okay. Otherwise, if you are not using boiled distilled water, then what we need to do? We need to seed the water for dilution so that sufficient bacterial growth will be there, right? And in such a case, the formula will little bit alter, and the formula will be like this: that BOD of mixed sample minus BOD of water for dilution. Okay. Now to carry out such an experiment, 2 bottles of BOD should be taken. One should be seeded, another should be unseeded, right? That is called blank. Okay. And BOD of this particular water, if we see it, the formula that will be used is this one, right? BODW is equal to BOD DOI minus DO5, the previous formula, minus BI minus B5. Now what is BI and B5? BI is initial DO of the seeded solution, and B5 is the solution after 5 days. Okay. 1 minus F is dilution factor that we people already know, right? Okay. And DO of 5 and DOI has their usual significance. Okay. Let us go to the next slide. Now calculation of BOD. How BOD is calculated. Now what we are having here, see, normal BOD5 is equal to D1 minus D2 by F. If we know that what it is it is a decimal volumetric fraction of sample used. D2 is sample after 5 days and D1 is initial. So basically DI and D5 has now become D1 and D2. If 100 ml of sample are diluted to 300 ml, then F is 0.33. Note that there is no dilution is necessary. F is 1 and the BOD is determined by D1 and D5, right? So if there is no dilution, no need to take F. If there is dilution, we need to take F. Okay. If more than one dilution of the sample results in residual DO, then DO depletion for at least 2 mg per liter, there is no evidence of toxicity at higher sample concentration or the existence of an obvious anomaly. Average results that are acceptable in range, right? Okay, so this was all about the calculation of BOD. Let us go to some other thing. BOD reaction rate constant. See, basically the reactions that occur in BOD bottle as well as streams are very complicated. Okay, first order, half order, second order. Now here we need to know about chemical kinetics. I think you remembered chemical kinetics. Okay? Zero order, first order, second order, half order, that we people have studied, but I think you people have forgotten. Okay, now no need to remember that again. Just we should remember that y is equal to L1 minus e to the power 1. This will be e to the power minus kt. Okay, this is the exponential factor. Actually, it has come down, but this particular fraction, it will come on the power of e. Okay, right? Where y is the BOD consumed, L is ultimate first stage, K is as usual the rate constant, T is time. Under such condition, this is the formula. I think you remember this particular formula. It's a very common formula for chemical kinetics, right? Okay. So this is a formula with which we'll do the numericals, right? Let us see. More explanations will be given in the next page, I guess. Now, what is chemical oxygen demand? This is another very important topic. Now, there are two terms basically. One is BOD, another is COD. Right? Again, I'm saying COD doesn't mean cash on delivery. It means chemical oxygen demand. Okay. Let us see what COD is saying. See, during COD determination, total organic content of the water is oxidized by dichromate. It is also called basically why it is called chemical oxygen demand, because here chemicals are used for oxidation, right? Here basically chemicals are used for oxidation. Okay. Now in this test, what we are doing, we use chromate, dichromate solution. In this test, we determine the oxygen requirement of wastewater. Strong oxidizing agent like potassium dichromate is used. Now, from our knowledge, we can say potassium dichromate, not only it is used, but also sulfuric acid will be used. And yes, acidic environment is provided by addition of sulfuric acid. So basically, sulfuric acid and potassium dichromate together they form chromic acid, H2CrO4, which is very, very strong acid. Okay. Now we have to make the solution reflux, right? It is heated to 150 degrees Celsius for 2 hours with silver sulfate as catalyst. Okay. So when silver sulfate is used, the recovery of most organic compounds is greater than 92%. So it is very good percentage. COD test measures virtually all oxidizable organic compounds, whether biodegradable or not, except some aromatic compounds which resist dichromate oxidation. See, almost there is no compound which can resist from dichromate oxidation, which is a very strong oxidizing agent. But apart from these few compounds, all the compounds are taken into consideration in COD calculation, right? And it's proportional to BOD, but for readily assembled organic matter in dissolved form, that is sugars, right? So basically it is proportional to BOD, but COD is much better process than BOD because we are not depending on the microorganisms. Rather, we are adding strong oxidizing agents which are much better effective compared to BOD. But BOD is a separate process, COD is another separate process, right? So we cannot compare them directly, but COD process, I think it is better because directly you apply chemicals and you get the accurate result. Okay. Also, we need not wait for 5 days, 10 days, right? Only 2 hours and few more time is required. Okay. So within a few hours you can get the result, right? So this was all about the BOD and COD tests, and as you know, this is very important thing for us, since this particular studies will give us better idea about what the quality of water is. Right now, you have seen how BOD is conducted, how BOD test is conducted. Now study it well, and if you face any problem, it may happen that you are facing problem because there are numericals, right? So we have discussed the numericals here. If you face any problem, just contact me and we will solve it out. Okay. So see you in the next lecture. Until then, stay safe, stay healthy. Thank you so much.